Hi, I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us today. You know, when we talk about optimizing primary storage, we tend to focus on either optimizing performance using caching technology or tiering, or we try to optimize capacity using probably like an archiving technique. We hardly ever talk about doing both things at the same time, optimizing performance and capacity. To join me to discuss that is Mark Cree. He is the CEO and founder of InfiniteIO. Mark, thanks for joining us today.
Thank you.
So Mark, you guys have been kind of looking at this. What do we need to do or have to be able to optimize both performance and capacity at the same time?
Well, one of the things that we found at InfiniteIO is that if you think about the typical storage system, this would be NAS, two things that we can pretty much assume are going to happen with every NAS system is that 80% of the data on that NAS system is going to be inactive or more, right? So let's say 80% inactive. The other thing that most people do not realize, George, is that of the requests going to the storage system, we tend to find that 70 to 90% of the requests going to the storage system are for metadata.
I think that is a surprising number for most people. Just real quickly, in case people aren't clear, explain what metadata is versus data.
So metadata is data about data. The most common one is get attributes. Somebody program's trying to figure out if a file's been opened, if it's closed, who touched it last.
Okay, that makes sense. And so obviously that would be something that happens all the time, right?
Yes, and as we found, the storage systems are really optimized to push data in and out. They're really not optimized at all to serve metadata.
Okay.
And when you get 90% of your requests going to a storage system being metadata, it really slows things down.
Right. And most file systems, I would assume, embed the metadata right with the rest of the data, right?
Exactly.
Yeah, okay.
Exactly. So with those two assumptions, what we did in InfiniteIO is, okay, if there's some way we can offload this metadata processing to the network, we can get a big performance boost. So what we do is we install our device in the network in front of a storage system. And our technology is very unique in that what we've done, this would be clients and servers, if I spelled that right, is that we've built a product that has no file system. Basically, what we're using is deep packet inspection. So as packets flow by us, we're literally looking inside those packets for read and write commands, which is really unique. Now, you might say, well, how do we think of this? Most of our development staff came from a security company called Tipping Point that at one point, they had an intrusion prevention system that looked in basically every packet for an intrusion.
Makes sense.
So we said, okay, hey, why don't we use the same technology and start looking at storage traffic?
Okay.
So we install our box in front of this NAS here, and the first thing we'll do is we'll start learning the metadata as we see it go by.
Okay.
So as a file gets written, the post-op header will come by and we'll update our metadata. So we keep the metadata current for what's on it, and ultimately what we end up building is a database of all the metadata here that's on the storage system in DRAM.
And all that's happening transparent, so I don't need to do anything.
And the beauty of this thing is we're called a layer 7 transparent proxy. What that means is whatever your mounting points were back here, so let's, in Microsoft world, let's say you had drive letter D, even though we're doing all this packet processing, the customer or the clients and servers see drive letter D. Okay. There's no mount changes whatsoever, which is really, really unique in the industry. We're actually filing 10 patents on this right now. We've got another 30 patents in the works. So that's the first thing. So now we're learning metadata. We also do a one-time scan of all the metadata in the storage device to get all the metadata in here. So now there's no cold spots whatsoever.
Yeah, that would make sense. If 80% of the data is inactive, you might not ever see it if you don't have a way to scan it.
Exactly.
Right? Okay.
So now what happens is this is mind-boggling performance. So metadata operations being done on a typical filer tend to be in the 900 microsecond to the 2+ millisecond range. Okay. Which still is fast. This is the fastest flash systems out there. We're serving metadata on our device in a cluster. We can have multiple of these boxes stacked up here. If you come in and out of the same box, it's in the 40 microsecond range. If it's comes in one box and goes out another box, it's 77 microseconds. Wow. So we're talking
substantial.
We're talking 20, 50 times faster than storage behind us. Okay. We literally have had customers install our product and call us back saying, I don't know what we did, but all of a sudden my clients are calling me saying, my simulations got cut to 1/10.
Wow. Yeah.
So that's the first thing. Now that we've got the metadata abstracted here in the network, we can do some really cool things about that inactive data. Remember, so now we've solved the performance issue here. The next thing is, okay, we've got this 80% down here that's inactive. Okay. We have a copy of all the metadata now for that inactive data. So what we can do is basically connect our product to a cloud or object store. We'll just say it's an object store.
Okay.
But this could be Amazon, Google.
Okay.
We don't care.
Or it could be an on-prem object store as well.
And that's really what we see most often is they're buying something on-prem.
Okay. So how do you manage making sure the right data gets to the right place like that?
Okay. Well, once we get all that metadata in this device, our box, essentially we've got a map of all the storage metadata for the storage behind us. So we're keeping that current by watching packets go by. So what the client can do is basically run policy. So basically go into our user interface and create policies. We typically set them do something like, hey, anything older than 90 days is inactive, and have exclusions and inclusions. So always move stuff off of George's directory and never do it for Bob's. And what we'll do then is we'll read this 80% off of the storage here, bring it into InfiniteIO, chop it into objects, chunks, which are objects, compress them, and if they're going to a public cloud, we have a local key safe. We can key it as well. But ultimately what happens is 80% moves from here up into the cloud. But again, with our technology, since we're totally transparent, it looks like that data is still all sitting on that local array.
So I don't need to change anything on the client or the server side.
No, and the cool part about this is, like other tiering systems, we've only scanned once. We never have to scan again. It's always done on our metadata here, so you don't get the performance hit. You don't have any stub files because, again, we have the metadata, so we know where everything is, so there's no reason to have a stub. If we see a request come in, so let's kind of run through the different requests.
Okay.
So let's say it's a metadata read to the local storage here. What we will do then is we'll see that request come in and serve it out of our box at 77 microseconds or less. If it's a read or write to the actual NAS system, we'll let that pass through. That the NAS continues and does that transaction, sends out a post-op header. We see the post-op header, and then we update our metadata based on that. Now, if they did their policies right, they're probably not going to be going to the cloud very often. Usually we see that being less than 5%.
Okay.
But back to our rule here, if 70, 90% of the requests are for metadata of that 5%, 90% of the time you're serving it out of...
And not touching the cloud.
Exactly. We're going to give that cloud, we're going to make it look faster than a flash array for most accesses.
Wow.
Which is really cool. You're actually getting low-cost tiering and higher performance.
Yeah. I almost drew a light bulb going on right above my head here when you said that. I was like, oh my gosh, you don't have to go. If it is in the real cloud, you save that whole bandwidth connection.
So that was actually the original idea we had. That's why we put the metadata here. But what happened is we started installing our box and customer sites, and they said, can we just get this part first? Can we just have the speed up and we can add the cloud part later?
Interesting.
So the case we actually are reading a file back from the cloud, what we'll do then is we'll feed the application or the client the metadata. Okay. And then we'll stream it from NFS or SMB, or I'm sorry, from object back to NFS or SMB, and the customer doesn't even see it. So kind of another example here might be, well, let's say you're going to do a directory read. Okay. You might say, well, how do we show this as one solid thing? Basically what will happen is we'll see that directory request, we'll query the filer, shoot the files back, and then we'll append it with the files that are in the cloud. So to the clients and servers back here, it looks like they're still sitting on, let's say this is a NetApp. It looks like it's still on the NetApp, even though we're moving stuff to the cloud back and forth in real time.
Wow. Okay. So then, Mark, what I'm seeing here is with your guys' system, once it's in, transparent access to data no matter where it is. So we've really fixed the 80% inactive problem, which we've used that 80% inactive, I think, since the beginning of data centers, right?
Yes.
So to be able to solve that is really interesting. But we never talk about this metadata and this performance increase that people are going to see. It has got to be, and I think what's important here is even if this is an all-flash array, they're still being impacted by this metadata hit, right?
Yes, we've got customers putting us in front of flash arrays. And what you get there is you get a double performance bump, George. You get the fact that we're offloading the metadata here, so now this flash array can focus on just caching real files. Yeah. So you really get a double bump in performance.
Wow, that's amazing. Well, Mark, thanks for joining us today.
Thank you.
So there you have it. If you're looking to really solve the two big problems with Filer and NAS and things like that, which is performance and capacity, look at this InfiniteIO solution. It's a totally unique way of addressing the problem, one that we haven't seen before. But to be able to offload that 80% of inactive data to an object store to cloud, and then to increase performance with this metadata enhancement is really worth checking out. I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us.